Okay, we're going to wrap up this section with a few more examples, applications of the normal distribution. This problem, the Bank of Connecticut issues Visa credit cards and estimates the balance on all Visa credit cards issued by the bank have a mean of 845 and a standard deviation of 270, follow a normal distribution. We have two parts to this. Part A, what is the probability that a randomly selected Visa card issued by this bank has a balance between 1,000 and 1,440? So that between is kind of a tip-off of a process. So we need to find the z-scores and the probabilities for these two data values. Again, when we're doing the between, I like you to try to remember to stack your problems as you're working across, and to find the z-score and probability of our larger data value first. So 1,440 minus 845 divided by the standard deviation of 270 gave us a z-score of 2.2. When we check out the probability that is associated with a z-score of 2.2, either using the standard deviation, or I'm sorry, the normal distribution chart, or your calculator, I guess, you would find that you'd have a probability of 0.9821. We work through the same process with the balance of 1,000. We have a z-score of 0.57. The z-score that is associated with, I'm sorry, the probability that's associated with the z-score of 0.57 is 0.7157. I found these on the normal distribution chart. I'm not going to bother pulling that up. I'm hoping that we're comfortable doing that at this point. Okay, so if we have this in this order, we automatically have our probabilities stacked, so it's easy for us to subtract to find the difference between these two probabilities, which is 0.2704. If we draw our curve and plot our z-scores on the lower horizontal axis, and then on our curve, our data values, we are shading in between the 1,000 and the 1,440. This shaded region represents the 27% that have a balance between 1,000 and 1,440. Okay, so our next part, what are the percentage of Visa cards issued by this bank? What percentage of cards have a balance of 730 or more? So we're going to do that second part down here, and that's pretty straightforward. We've done this before, just a z-score formula, data value minus the mu, come up with a negative 0.43. We try to find the probability that is associated with a z-score of negative 0.43. We come up with, on our chart, 0.3336. But we need to remember, this is the area to the left. Our question is asking for a balance of 730 or more. So that's kind of a tip-off that we need to the right. So we're going to have to use our complement of this to come up with 0.6664. I'm hoping that I could do this on StatCrunch for you right now. So when I go into StatCrunch, I'm going to do calculators down to normal. We get our regular defaults here, but we need to put in our information. We have 845 for the mean, standard deviation of 270. Our first one, we're looking for a between, so I need to hit the between up here. I'm going to put our lower value, our data value is 1,000. Oops, not negative 1,000. 1,000 and 1,440. Hit compute, and it draws the picture for me, and that matches the picture that we had drawn. So now I'm going to go back and do the second part. So I'm going to put it to standard. It maintained the mean and the standard deviation. In this case, I'm looking for greater than the data value of 730. So I put in 730 here. But I remember I'm looking for greater than 730. And so it showed me the picture, and it tells me the percentage that we came up with. So I'll close that down, and we will continue on with our next problem. In this one, scores on a creativity test are normally distributed with a mean of 63.2 and a standard deviation of 11.7. We've got some new notation here. Find P of 80, or the score, X, that separates the bottom 80% from the top 80%. So in other words, we're looking for the data value, the score, that correlates to an 80% in this test. So we're looking for that score that is associated with 0.800. Now I can pull up the standard normal chart, come around in here, and I'm looking for 0.88 or 0.800, and that's going to give us right in here, sorry, 0.8, right in here, about halfway between. 0.84 is pretty darn close to it. So that is how we came up with this 0.84. So the z-score that is associated with a probability of 0.8 is 0.84. So we're going to plug that in and work backwards, do our algebra going backwards. We have to multiply both numerator and denominator by this fraction to clear the fraction out of the right side of the equation. Collecting, we find that we have a score of 73, separates the lower 80% from the upper 20%. So opening that up in StatCrunch, stats, calculators, normal. We've got to put our information about the test scores, creativity score 63.2, standard deviation of 11.7. Okay, now this one's kind of weird because we are looking for the data value. We know the probability, so we're going to put in 0.8, and it's going to give us the score nearest to a probability of 0.8. And it wouldn't matter if we put greater than or less than. This is we're looking for the data value that separates those two. So that's that one. Onward to our last problem in this section. The length of human pregnancies is normally distributed with a mu of 266 days and standard deviation of 16 days. Find the length of pregnancy for the middle 95% of pregnancies. Okay, this means that we would have to have 2.5% on each tail to split that 5% that's outside in order to identify the middle 95%. So we need z-scores for 0.0250 and 0.97, that should be 50. Forgive my error there, please put 0.9750. We need to find the ones that are associated to those probabilities. We could hunt in the chart again and find that we'd have negative 1.96 and positive 1.96 are the two z-scores that are affiliated with those probabilities. Again, we're doing a between, so we're looking at the lower. We're kind of doing the between as well as plugging in the solving for the variables. So we're setting up this algebra, having to work backwards to find that our lower value would be 234.64. Our upper value would be 297.36. When I draw the curve, you can kind of see you're looking for the middle 95%. You're looking for the lower limit and the upper limit that caps those. So doing this in StatCrunch, I'm going to go to Stats, Calculators, down to Normal. Okay, so this one we're doing a between problem, and I want to put in my mean of 200, what's my problem, 266, and our standard deviation of 16, I believe. And this time we want to know, we're looking for data values, so I need to erase these two things. And we're looking for the middle 95%, so I'm going to go 0.95, and I believe StatCrunch miraculously knows that we are looking for the middle 95%. And so it'll find the lower limit and the upper limit, which matches what we came up with. Lots of thinking going on here.